Chapter 13, Lesson 3, Sources of Energy. On page 387 on the right-hand side, you'll see the what you'll learn for our objectives today. Students will explain what renewable, non-renewable, and alternative resources are. Students will describe the advantages and disadvantages of using various energy sources. Let's get into our reading for today. Using energy. Every day, energy is used to provide light and to heat and to cool our homes, schools, and workplaces. According to the law of conservation of energy, energy can be created or destroyed. Energy can only change form. If a car or refrigerator can't create the energy they use, then where does this energy come from? Well, the answer is energy resources. Energy resources. Energy cannot be made, but must come from the natural world. As you can see in figure 16, the surface of Earth receives energy from two sources, the sun and radioactive atoms in Earth's interior. The amount of energy Earth receives from the sun is far greater than the amount of energy generated in the Earth's interior. Nearly all the energy you use today can be traced to the sun. Even the gasoline used to power the car or school bus you came to school in. First of those is fossil fuels. Fossil fuels are coal, oil, and natural gas. Oil and natural gas are made from the remains of microscopic organisms that lived in Earth's oceans millions of years ago. Here's where we would defer and say that those things were made with age, not that the Earth is millions of years ago because of our belief in creation. But God created these things. Heat and pressure gradually turned these ancient organisms into oil and natural gas. Coal was formed by a similar process from the remains of ancient plants that once lived on the land, as shown in figure 17. Through the process of photosynthesis, ancient plants converted the radiant energy in sunlight to chemical energy stored in various types of molecules. Heat and pressure changed these molecules into other types of molecules as fossil fuels formed. Chemical energy stored in these molecules is released when fossil fuels are burned. So time, which we would factor in to say that that's how God created it, heat and pressure take what was normally biomass material and turn it into these different types of products. So different types of plants create different types of fuels, and different types of geography and environment create different types of kind of reservoirs for this, like a coal mine or where you're going to find oil and natural gas. Using fossil fuels. It takes millions of years to replace the drops of gasoline in each lump of coal that's burned, but we're factoring in that God has already created these things, and now we're developing different ways to sustain this, because obviously if it's a non-renewable resource, we can't continue to use it up at the rate that we're using it. The energy used when you ride in a car, turn on a light, or use electrical appliance usually comes from burning fossil fuels. However, it takes millions of years to replace each drop of gasoline and each lump of coal that is burned. This means that the supply of oil on Earth will continue to decrease as oil is used. An energy source that is used up much faster than it can be replaced is called a non-renewable resource. Fossil fuels are non-renewable resources. Burning fossil fuels to produce energy also generates chemical compounds that cause pollution. Each year, billions of kilograms of air pollutants are produced by burning fossil fuels. These pollutants can cause respiratory illness and acid rain. Also, the carbon dioxide gas formed when fossil fuels are burned might cause Earth's climate to warm. A lot of people who are proponents of what's called climate change say that because we're using so much fossil fuels, we're releasing so much CO2, that's what's called a greenhouse gas, and that's what's creating the different types of warming that's happening on the Earth. Now, that's a collection of scientists that believe this. There are other people that believe otherwise and are skeptical of this as well. Nuclear energy. Can you imagine running an automobile on 1 kilogram of fuel that would release about almost 3 million times more energy than 1 liter of gas? Well, what could supply so much energy with so little means or so little mass? The answer is the nuclei of uranium atoms. Some of these nuclei are unstable and break apart, releasing enormous amounts of energy in the process. This energy can be used to generate electricity by heating water to produce steam that spins an electric generator, as shown in figure 18. Because no fossil fuels are burned, generating electricity using nuclear energy helps make the supply of fossil fuels last longer. Also, unlike fossil fuel power plants, nuclear power plants produce almost no air pollution. In 1 year, a typical nuclear power plant generates enough energy to supply 600,000 homes with power and produces only 1 cubic milliliter or meter of waste. So it lowers the waste. It's an unstable item to work with, so there's a lot of safety precautions that have to go into it, but it reduces our need for fossil fuels, and it's a much more efficient form of energy. Nuclear waste. Like all energy resources, nuclear energy has its advantages and disadvantages. One disadvantage is the amount of uranium in Earth's crust, which is a non-renewable resource. Another is the waste produced by nuclear power plants is radioactive and can be dangerous to living things. Some of the materials in the nuclear waste will remain radioactive for many thousands of years. As a result, the waste must be stored so no radioactivity is released into the environment for a long time. One method is to seal the waste in a ceramic material, place the ceramic in protective containers, and then bury the containers far underground. However, the burial site would have to be chosen carefully so underground water supplies aren't contaminated. Also, the site would have to be safe from earthquakes and other natural disasters that might cause radioactive materials to be released. Because these materials are radioactive means that they can give off radiation and then they can manipulate and affect things that would be harmful to humans or other living organisms. If it would get into the water would be bad to drink. If it would get into some of the different plant life or affect some of the native species of wild animals or wild plants, that would be detrimental to the environment overall. So the waste has to be taken care of in really specific ways. One way is to put it in these ceramic containers and then to bury it underground, but that underground burial place has to be really particular in terms of where you're putting it. Hydroelectricity. Currently transforming the potential energy of water that is trapped behind dams supplies the world with almost 20% of its electrical energy. Hydroelectricity is the largest renewable source of energy. A renewable resource is an energy source that is replenished continually. As long as enough rain and snowfall continue to keep rivers flowing, hydroelectric power plants can generate electrical energy as shown in figure 19. So you put water behind a dam, which creates potential energy, because potential energy is the energy of something that could move, and you allow some of it to move by how open that dam is, and you're going to spin a turbine. That kinetic energy turns directly into electrical energy. It's fast, efficient, and it doesn't have any form of waste. The only thing that you're going to be messing up here would maybe be the flow of water naturally there and the ecosystem that would have been naturally in that type of an environment. It is a renewable resource that is constantly replenished by the natural water cycle, the precipitation that we get at all different times of the year. So because it's winter, there's still water that's flowing in the rivers, even though it might freeze over the top of the rivers. And when it's snowing, that snow that accumulates a lot of times in higher elevations, then when it melts in the spring, flows downhill to create that potential energy, that kinetic energy of that moving water. Although production of hydroelectricity is largely pollution-free, it has one major problem. It disrupts the life cycle of aquatic animals, especially fish. This is particularly true in the Northwest, where salmon spawn and run. Because salmon return to the spot where they were hatched their eggs, the development of dams has hinged a large fraction of salmon from reproducing. This has greatly reduced the salmon population. Efforts to correct the problem have resulted in plans to remove a number of dams. In an attempt to help fish bypass some dams, fish ladders are being installed. Like most energy sources, hydroelectricity has advantages and disadvantages. So in terms of the pollution and affecting the environment, you'd say it doesn't have many disadvantages, but the one is disrupting the natural ecosystem of the different types of plants and aquatic life that live there. Messing up the fish population is one of those ways in which dams have become an issue, so they're trying to find other ways to engineer kind of solutions to having these dams there so you can have both the energy production and the natural ecosystem surviving. Alternative sources of energy. New sources of energy that are safer and cause less harm to the environment are called alternative sources of energy or alternative resources. Electrical energy can be generated in several ways. However, each has disadvantages that can affect the environment and quality of life for humans. Research is being done to develop new sources of energy that are safer and cause less harm to the environment. These sources are often called alternative resources. They include solar energy, wind, and geothermal energy. They're also known as renewable resources or inexhaustible resources because you can't run out of them. Solar energy. The sun is the origin of almost all energy that is used on Earth. Because the sun will go on producing an enormous amount of energy for billions of years, the sun is an inexhaustible source of energy. An inexhaustible resource is an energy source that can't be used up by humans. Each day on Earth, the amount of solar energy that strikes the United States is more than the total amount of energy used by the entire country in a year. However, less than 0.1% of the energy used in the United States comes directly from the sun. One reason is that solar energy is more expensive to use than fossil fuels. However, as the supply of fossil fuels decreases, the cost of finding and mining these fuels might increase. Then it may be cheaper to use solar energy or other resources to generate electricity and heat buildings than to use fossil fuels. So in one day, the sun produces enough electricity just in the United States to power the United States for an entire year. We're talking 24 hours, which in reality is less than that in terms of the amount of sun, the length of the sun being out. So say it's 12 hours or even maybe less in the wintertime. In that 12 hours, we produce enough electricity from the sun, or we could harvest enough electricity from the sun through solar energy to power all of our devices for an entire year. An incredibly efficient way in which we're going to try to use that energy resource or gain that energy resource, but it's an expensive way in which to go about gathering that resource. Fossil fuels are relatively cheap and inexpensive, so we use those more often than we do the different types of technology for solar energy. Collecting the sun's energy. Two types of collection or collectors capture the sun's rays. If you look around your neighborhood, you might see large rectangular panels attached to the roofs of buildings or houses. If, as in figure 20, pipes come out of the panel, it is a thermal collector. Using a black surface, a thermal collector heats water by directly absorbing the sun's radiant energy. Water circulating in the system can be heated to about 70 degrees Celsius. The hot water can be pumped throughout the house to provide heat. Also, the hot water can be used for washing and bathing. If the panel has no pipes, it is a photovoltaic cell or photovoltaic collector, like the one pictured in figure 20. A photovoltaic is a device that transforms radiant energy directly into electrical energy. Photovoltaics are used to power calculators and satellites, including the International Space Station. Our reading progress says, what does a photovoltaic do? It's a converter of radiant energy into electrical energy. A photovoltaic cell looks like this. It's got these panels here, or also called a solar panel. Photovoltaic cell is just the scientific name that it's given. We actually have some of these on the roof of garden homes that power some of the electricity that you and I are using in our classroom each and every day. Geothermal energy. Imagine you could take a journey to the center of Earth down to about 6,400 kilometers below the surface. As you went deeper and deeper, you would find the temperature increasing. In fact, after going about 3 kilometers, the temperature could have increased enough to boil water. At a depth of 100 kilometers, the temperature could be over 900 degrees Celsius. The heat generated from inside the Earth is called geothermal energy. Some of this heat is produced when unstable radioactive atoms inside Earth decay, converting nuclear energy to thermal energy. At some places deep within the Earth, the temperature is hot enough to melt rock. This molten rock or magma can rise up close to the surface through cracks in the crust. During a volcanic eruption, magma reaches the surface in other places. Magma gets close to the surface and heats the rock around it. So, at some places, the crust and the mantle are actually relatively thin, so you can actually harvest some of this energy. But it's naturally being produced because of the pressure of all the weight of the Earth pushing down on everything that's inside of it. Geothermal reservoirs. In some regions where magma is close to the surface, rainwater and water from melted snow caps can seep down to the hot rock through cracks and other openings in their surface. The water then becomes hot and sometimes can form steam. The hot water and steam can be trapped under high pressure in cracks and pockets called geothermal reservoirs. In some places, the hot water and steam are close enough to the surface to form hot springs and geysers. If you've ever heard of Old Faithful in Yellowstone National Park out in Wyoming, you've seen or heard of a geyser in which the water fills up in this cavern, and because it's close to where there's different types of magma inside of the Earth, it then releases this huge spray of water and steam into the air every so many minutes because it's so close to where this geothermal reservoir is inside of the Earth. Geothermal power plants. In places where the geothermal reservoirs are less than several kilometers deep, wells can be drilled to reach them. The hot water and steam produced by geothermal energy can be used by geothermal power plants like the one shown in figure 21 to generate electricity. Most geothermal reservoirs contain hot water under high pressure. Figure 22 shows how these reservoirs can be used to generate electricity. While geothermal power is an inexhaustible source of energy, geothermal power plants can be built only in regions where geothermal reservoirs are close to the surface, such as the western United States. So we can't have them here in Wisconsin because we don't have a lot of volcanic activity really close to where the crust meets where this water could actually drill down into. If you look at the picture on the bottom of page 393, you can see how there are pipes that are drilled down into the different fractures in the rock where that hot water or geothermal reservoir forces that energy to be pushed up into the generator. That moving water again creates the type of electricity that's flowing because of that way in which it's heated up. Here's a picture of how that goes. So you've got warm water and steam that's coming up because it's under high pressure because of the magma that heats this rock and this water up in this area, and you pump water back in, and it creates this cycle of a working geothermal power plant. But it can only be used in certain parts of the United States where you have a limited amount of space between where the crust is and the magma actually operates and shows up. While geothermal power is an inexhaustible resource, geothermal power plants can only be built in certain regions. Western United States is one of those examples. Heat pumps. Geothermal heat helps keep the temperature of the ground at a depth of several meters at a nearly constant temperature of about 10 degrees Celsius to 20 degrees Celsius. This constant temperature can be used to cool and heat buildings by using a heat pump. A heat pump contains a water-filled loop of pipe that is buried to a depth where the temperature is nearly constant. In the summer, the air is warmer than this underground temperature. The warm water from the building is pumped through the pipe down into the ground. The water cools and then is pumped back to the house where it absorbs more heat, and the cycle is repeated. During the winter, the air is cooler than the ground below. Then cool water absorbs heat from the ground and releases it into the house. So because the water stays at a relatively common temperature, it's either going to be cooler than the air, and that air is going to, the hot air is going to heat up that cool water, therefore absorbing that energy, or the water is going to be hotter than the air, and then it's going to release that heat and provide heat to your home. So either it's heating or cooling, depending on the season and depending on what that temperature is. Because we learned that thermal energy goes from a higher level to a lower level. You can use this technology in the form of a heat pump to maintain a relatively constant temperature throughout the house. So water cools, it's pumped back to the house where it absorbs more heat, and the cycle is just simply repeated. During the winter, the air is cooler than the ground below, and the water absorbs the heat, and the heat is released into the house. So it can either heat up or cool down through that consistent loop. Energy from the oceans. The ocean is in constant motion. If you've been to the seashore, you've seen waves roll in. You may have seen the level of the ocean rise and fall over a period of about half a day. This rise and fall in the ocean level is called a tide. The constant movement of the ocean is an inexhaustible source of mechanical energy that can be converted into electrical energy. While methods are still being developed to convert the motion in ocean waves to electrical energy, several electrical power plants use tidal motion to harvest this kinetic energy. Using tidal energy. A high tide and low tide each occur about twice a day. In most places, the level of the ocean changes by less than a few meters. However, in some places, the change is greater. In the Bay of Fundy in eastern Canada, the ocean level changes by 16 meters between high tide and low tide. Almost 14 trillion kilograms of water move into or out of the bay between high and low tide. Figure 23 shows an electrical power plant that has been built along the Bay of Fundy. This power plant generates enough electricity to power about 12,000 homes. Power plant is constructed so that as the tide rises, water flows through a turbine that causes an electrical generator to spin, as shown in figure 24A. So as water goes up and down, there's going to be water that moves through this turbine that generates that electricity behind this structure, behind this dam. The water is then trapped behind a dam. When the tide goes out, the trapped water behind the dam is released through the turbine to generate more electricity, as shown in figure 24B. So then it's caught behind this dam. As it goes back out into the ocean, it's going back through the turbine and again producing electricity for a second time. Each day electrical power is generated for about 10 hours when the tide is rising and falling. While tidal energy is non-polluting and inexhaustible energy source, it is limited. Only in a few places is the difference between high and low tide large enough to enable large electrical power plants to be built, and it only is producing electricity when it's high and low tide, when there's that change that's taking place. It's not like it can constantly produce electricity regardless of what time it is or what the circumstances are where the tide is. Wind power. Wind is another inexhaustible supply of energy. Modern windmills like the ones in figure 25 convert the kinetic energy of wind to electrical energy. The propeller is connected to a generator, so the electrical energy is generated when wind spins the propeller. These windmills produce almost no pollution. Some disadvantages are that windmills produce noise and that large areas of land are needed. Also, studies have shown that birds sometimes are killed by windmills. So they do kind of look weird. They take up a lot of space. They're kind of noisy if they're built in an area that you live, but they can constantly produce electricity for us, which is sometimes an advantage that overtakes some of those disadvantages. Conserving energy. Fossil fuels are valuable resources. Not only are they burned to provide energy, but oil and coal are also used to make plastics and other materials. One way to make the supply of fossil fuels last longer is to use less energy. Reducing the use of energy is called conserving energy. You can conserve energy and also save money by turning off lights and appliances such as a television when you're not using them. Also, keep doors and windows closed tightly when it's cold or hot to keep heat from leaking out of your house. Energy could also be conserved if buildings are properly insulated, especially around windows. The use of oil could be reduced if cars were used less and were made more efficient, so they went further on a liter of gas. Recycling materials such as aluminum cans and glass can also conserve energy. Your assignment for today looks like this. Sources of energy. In the first section, it says, circle the term in the parentheses that correctly complete the following statements. 1, 2, 3, 4, 5. Circle that term or underline it. Make it real easy for Mr. Shane to see your answer. In numbers 6 through 10, determine whether each of the following statements is true or false. If it is true, write true on the line. If it's false, change the underlined term to make it true. You just have to change the term. You can write false and then change the term. False, change the term. False, change the term. If it's true, just write true on the line provided. 11, 12, and 13. Answer the following questions on the lines provided. 11 says, explain why it would be necessary for a home using solar energy to have some type of energy storage device. Well, that's probably because the sun's only out at certain times of the day, so you're only producing electricity when the sun is out. What if there's bad weather? What if there's clouds? Does it still produce that electricity? Probably not. Number 12, explain how hydroelectric energy works. I would look at the section in our textbook on page 391 that shows you the step-by-step process: potential energy of water, kinetic energy, electrical energy, and then the long-distance power lines. That's on the top of page 391 that explains how each step works in hydroelectric power. And 13 says, give it 2 advantages and 2 disadvantages to using fossil fuels. For that, you're going to go all the way back to page 388. The advantages would probably be that it's cheap and that there's a lot of this resource. The disadvantages would be that it's a non-renewable resource and probably the pollution that's coming from the different types of burning and usage of these fossil fuels. But you can find that again on page 388 for number 13. God's blessings.